In the last few videos, we reviewed exponent rules, and in this video and the next few videos, we're gonna review how to factor polynomials. Now, factoring, the word itself, what does it mean to factor something? It just means to turn something into a product. So for example, if I give you a number like 15 and say turn it into a product, you would say 15 is 3 times 5, and that would be basically factoring. Now, when we do factoring in this class, we're typically going to be factoring polynomials. So what is a polynomial? A polynomial is an expression that has x's and numbers. And the special thing about these x's is that they all have integer exponents that are positive or 0. So for example, the power here is 2, the power here is 1. Again, there's a 2 power and 1, 1 again, and 2 again. So these are called polynomials. Now, generally speaking, depending on the number of terms in a polynomial, you could use a different strategy to factor that polynomial. Now, what do I mean by the word term? What is a term? In mathematics, a term is an expression that contains a number and a variable. And typically speaking, terms begin and end where a plus or minus sign is found. So for example, the first example in this problem has 9x squared minus 9x. It is assumed that in front of the first 9 there's a plus sign. So that indicates the beginning of the first term, and the term ends where the minus shows up. So the minus indicates the beginning of the second term. So this is a problem with 2 terms. So depending on the number of terms, you will have a different strategy for factoring the polynomial. So typically speaking, that's the very first thing you want to look at when you are factoring a problem. How many terms does it have? And these are the strategies that we're going to be describing in the next few videos, as well as memorizing some formulas that will help us factor special products. So let's dive right into it. We are going to start with example 3, which says factor the GCF. Now, if you haven't heard those letters before or those words before, GCF just literally means greatest common factor. So this is a number that can fit inside of both of your numbers that are written down, or it's an expression that fits inside of the expressions that are written down. So for example, the first problem has 9x squared minus 9x. If I break it down, I could break it down like this. The first term, which has 9x squared, can be written as 9x and x again because of x squared. The second term can be written as 9 times x times 1. And as you can see, in the first term and the second term, there are some repeating factors. There are some repeating numbers and letters. So for instance, the 9 is repeating in both the terms, and one of the x's is repeating in both of those terms. So we would say that the GCF in this case is 9 and x. And so what we do is we grab the GCF, which is 9x that we circled, and we put it first. Then we open up a set of parentheses and we write down the leftovers. So what's left over from the first term when I erase the 9 and the x? The leftover is x. So we just put it inside of the parentheses. And the second term, if I take out the 9 and the x and write them in front of the parentheses, what would be left in that term? So watch out and be careful, because what's left here is negative and 1. So that's what gets written inside the parentheses. And that's pretty much the end of that. This is the solution. So 9x and then x minus 1. Keep in mind that there's nothing between the 9x and the parentheses. That means it's multiplication. And that means we actually worked out the problem correctly. We factored it. So the important thing here is to remember to break things down as much as possible and then look for repeating terms. So let's take a look at the second problem. The second problem says 16x squared times y and then 24x y squared. So let me go ahead and write it down. 16x squared y plus 24x y squared. What are the repeating factors? What's the common factor? Well, let's start with 16. I can break down 16 into multiple different ways. For example, I could do 2 times 8. I could do 4 times 4. I could do 2 times 2 times 2 times 2 4 times in a row like that. I'm going to pick 2 times 8. Next, I have x squared, which can be written as x times x. Then finally, I have the y, so I'm just going to write it at the very end. Now, similarly, I'm going to break down the 24xy squared in a similar way, just like I did with the first term. So there are, again, multiple ways of breaking down the 24, but I'm going to choose the one that says 3 times 8. Why am I choosing that? I'm choosing that because now I can see that the 8 is repeating twice. So that's the reason why I chose 2 times 8 first, and then 3 times 8 for the 24. Now similarly, the x has to be written once, and the y, because it has power 2, gets written down twice. And again, look for the repeating terms. So the repeating factors in the first term and the second term are, as we said earlier, the 8 is repeating already, x is repeating once, and y is repeating at least once. Well, in this case, just once exactly. So we're going to take those repeating terms, which are called the GCF. So in this case, the GCF is 8 and x and y, and we write that in front of the parentheses. So 8xy goes first, and then we open up parentheses and we put the leftovers. So what are the leftovers from the first term? Well, there's the 2 and the x. So they go in front on the first part of the parentheses. And then in the second term, what's left over? There's the plus left, there's the 3, and then finally the y. So those go second here. And we are pretty much done at this point. So 3 and y. And as you can see, this is a product, so that means we are completely done. Now finally, the last problem in this case has negative 25x squared plus 15x plus 5. And the special thing here is that my first term is a negative 25. So that's going to create a little bit of an issue. Whenever your first term is negative, you're going to have to factor a minus sign out with the GCF. So let's kind of look at it. Negative 25 could be written down as negative 5 times 5, and then x times x. The 15x can be broken down as 3 times 5 times x. And finally, at the end, there's the 5, which can be written down as 5, or 5 times 1 if you really want to. So how many terms do we have in this case? Let's count them. There's one term, a second term, and a third term. What is the common repeating factor? The common repeating factor is a 5. But at the very front in my first term, there's a negative sign. So the rule of thumb is this. If your first term in the list is negative, you want to factor the minus along with the GCF. Now, when we do that, this is what it's going to look like. You're going to have the negative and the 5 sitting in front. We're going to open up a set of parentheses, and we're going to need to put some stuff inside. So what do we put inside? Well, on the first problem, on the first term, it's pretty straightforward. We're just going to put the 5xx, which another term is 5x squared. So that's straightforward, nothing to do there, nothing to worry about. Now, what about the second term? We're taking away the 5, so what's left is, technically, what's left is a positive, a 3, and an x. Now, can we put that inside the parentheses? Would that work? Let's try it out. If I put a positive 3x here, the negative times the positive is going to be at the end negative 15x, but I didn't start with negative. I started out with positive 15x. So what does that mean? That means I have to modify. Because I factored a minus sign out, what gets written inside the parentheses is not a positive 3x, it's actually going to be a negative 3x. So everybody gets flip-flopped. So instead of positive 3x, I actually have to write down negative 3x. And similarly, the last term has a 1 and a plus. So instead of writing plus 1, I have to flip it around and write down a negative 1 instead. I have to take the opposite. That's because I factored a minus sign out. So I already took away the minus. So to make it balanced, I have to put another minus because minus times minus would be plus 5, which was originally there when we started off. So that completes the first problem. And this is the strategy we use pretty much at any point in time when we're told to factor. So generally speaking, whether it says factor the GCF or not, this is the method that I try first in any situation.